Now dear students, D block and F block elements. Some extra points I want to tell you now. Absorption spectra, these are quite characteristic of the compounds in chemistry, and this is applicable to D block and F block elements. We usually find the absorption spectra of D block elements will have very broad peaks, whereas if you consider the absorption spectra of lanthanide series of compounds, we find the absorption spectra of lanthanides are found to be very sharp, line-like spectra you will get, very sharp line-like spectra for lanthanides, unlike the case of D block compounds. Now it has been observed that, for example, 4f orbital is well inside the atom. It is very deep in the atom, and so it is not capable of forming ions quite readily. And these 4f electrons, since they are found very deep in the atom, we get usually the line-like spectra. One question may be asked, if we compare the absorption spectra of lanthanides and actinides, even though the common feature is both lanthanides and actinides are capable of giving absorption spectra, there is one main difference. The difference is this: lanthanides will have very sharp and line-like peaks, as already I have mentioned. But in the case of actinides, the main difference is the lighter actinides are just like transition elements or D block elements as far as the absorption spectra are concerned. That means lighter actinides will have a broad absorption spectra, because it has been noticed, unlike 4f, 5f orbital is somewhat exposed to environment, and because of this we find the lighter actinide elements will have absorption spectra more or less similar to transition metals. But at the same time, if you come to the heavier actinides as far as the absorption spectra are concerned are lanthanide-like. That means heavier actinide elements will have, just like lanthanides, very sharp and line-like spectra. So usually this statement we can find in higher level chemistry books, namely heavier actinides will have lanthanide-like absorption spectra. That means as far as the heavier actinide elements are concerned, again the 5f is found to be somewhat deep, and those electrons in 5f in the heavier elements are not affected by the environment, and because of this the absorption spectra of heavier actinide elements will be similar to those of lanthanide elements. So D block elements on the one hand will have a very broad absorption spectra. Lanthanides will have very sharp line-like absorption spectra, whereas in the case of actinides we notice lighter elements similar to D block elements and heavier actinide elements similar to lanthanides as far as the absorption spectra are concerned. So a question, if it is asked, why this sort of difference between lanthanides and actinides regarding the absorption spectra. The reason is this. In the case of lanthanides, the 4f orbitals are very deep inside the atom, because of which the environmental effects will not be observed, and so we find sharp line-like absorption spectra in the case of lanthanides. In the case of heavier actinides, they follow lanthanides in having sharp absorption spectra, but the lighter elements, the 5f electrons, are affected by the environment, because of which their spectra will be similar to the transition elements spectra.